Welcome to HECTV's live interactive program that's part of St. Louis.
The whole production is pulled together.
It's going to be a steel bridge.
The way the cockpit is designed.
The highest rated green building in the world.
Welcome to HECTV Live.
Hi everybody, I'm Tim Gore and I'm very happy to welcome you right now to the Little Creek Nature Area where you're going to have a chance to interact with students from McClure High School and McClure North High School who get to participate in this unique and exciting outdoor education area which is part of the Ferguson-Florissant School District. Today we're going to talk about watersheds and water quality and how we test for water quality. There are three specific ways that you test for water quality and today you're going to get some students who are going to show you in a lab environment how that happens. As always, HECTV Live is interactive. If you're joining us via television or the web, then you can send us your email questions to live@hectv.org. That's live@hectv.org. We're also being joined by two interactive video conference schools throughout the program today, and we're going to have the chance for them to interact as well. But before we go to those students for interaction, we want to give you a chance to see a little bit of the Little Creek Outdoor Education Center. This comes to us from students at McClure North High School, their broadcast journalism class, who put this video together for us.
Little Creek Nature Area is a 97-acre outdoor educational facility owned and operated by the Ferguson-Florissant School District and located in North St. Louis County near I-270. Little Creek is largely wooded and preserved as natural areas with trails, ponds, and several tributary streams that drain into the Moline Creek watershed. Since 1974, teachers have provided ecology, AP Environmental Science, field biology, and living history programs for district students from pre-K through 12th grade. Hands-on, inquiry-based activities provide students with experiences which not only enhance achievement, but cultivate a lifelong interest in the natural world and meet cross-curricular objectives not easily accomplished in a traditional classroom setting. Students also participate in the stewardship work required to meet the challenges of maintaining a nature area in an urban setting. In the 30 years it has been in operation, Little Creek Nature Area has adapted to the changing needs of the district and community.
I want to introduce the experts here with us today as well as the students. So I want to turn over here to Eric Hadley, who gets to teach out here every day. Eric, thanks for joining us.
Absolutely.
Give the world a little bit of idea about what happens out here at Little Creek. You have an outdoor education center. That's pretty unique for a school district.
It's very unique. One of only 3 in the nation that has an outdoor education like we have here, where we see about 11,000 students throughout the year. Early education through 7th grade come out here several times a year. And then we also have a every day, once a day class for seniors from all 3 of our high schools that come out here and get to enjoy the outdoor classroom.
Well, great. Thanks for having us out today and giving the rest of the world a chance to go outdoors while being indoors, I guess, which is what we're going to do today as we look at ways that we test for water quality. We're also being joined by Jamila Harris from the Missouri Department of Conservation. Jamila, thanks for being here.
Thanks for having me.
Give the students an idea about what it is you get to do every day.
I'm a conservation education consultant, so my job is to do teacher workshops, outdoor classroom development, grant work. I coordinate special events like Eagle Days and then do some field trips with students that go along with our curriculum.
Ah, so you do this kind of thing on a pretty regular basis.
Yes.
Very cool. And to her left is Perry Eckhart, who's also with the Missouri Department of Conservation. You're an urban forester, right,
Yes,
Perry?
sir.
What does that mean exactly?
That means I help local communities, school districts with managing the trees on their property, and here it's very tied to the creek because this is a forested area, and whatever happens to the trees here are going to affect what happens down in the creek.
You all have a chance to ask Jamila and Perry questions throughout the program. Don't forget, if you're joining us via television or the web, you can send your questions to us at live@hectv.org. My trusty little iPad will be here to receive those questions, which we got a whole bunch in this morning's program. We're looking forward to more this afternoon. You saw some video of the Little Creek Nature Area that the Ferguson-Florissant students put together. Now we want to go live via Skype and test that connection because later in the program, Brianna and Evan are going to join us with a certain test for water quality. So let's go down to Brianna now and let her say hi. Brianna, come on in.
All right, hi, we're live at the creek in just a little minute. We're going to do a live turbidity watershed.
That's great, Brianna. Thanks very much. We're able to see and hear you just fine coming via Skype. And again, our thanks to Kevin Hampton and the students from the Ferguson-Florissant McClure North broadcast program for being down there with us and providing the cameras to make that happen today. Cool things happen in school districts all across the country, and today we're going live to this one in particular. Again, our interactive schools will be joining us through the program. Jamestown, Missouri, we know that you're with us in the bridge. I'll ask you to keep your microphone muted. We'll be coming to you for questions throughout the program. Our second interactive school comes today from Canton, Ohio, Arts Academy at Summit. As they come into the bridge, we'll be interacting with them as well. We look forward to your questions throughout the program. To start with, we want to give you some just general information about what is a watershed and what that matters. So we're going to ask Caitlin to join us over here. Caitlin, thanks for being with us.
Hello.
So when we say a watershed, what does that mean exactly?
All that a watershed really is when rainwater falls and collects in an area, the area that it collects in is called the watershed. And at Little Creek, our watershed is made up of the creek and the pond. And then that all flows eventually into the larger St. Louis area watershed, which is the Mississippi River.
And of course, you guys had the chance to see some video of the Little Creek area, but if we look at this model right here, this is an example of a watershed, right?
So if we just spray water on here, you see it at the highest point of elevation, then it collects down into lower elevations, and eventually would create rivers and streams, and that's a watershed.
So obviously things that happen up on top, so to speak, definitely affect things that happen
Absolutely,
further
it's all
downstream.
interconnected.
So when we look at the water quality that we're going to see here at Little Creek, it's being influenced not just by the vegetation or whatever's happening right here in St. Louis, it's being influenced by what happens upstream too.
Absolutely.
And that's an important thing to think about because obviously everything's interconnected. And as you think about controlling the quality of water, you've got to look not just at the site where you're getting the water from, but also at other places that are affecting the water further upstream.
Yes.
Thanks, Caitlin. Looking forward to connecting with you throughout the program. Some basic information about a watershed. We're going to be doing 2 lab activities in today's program. The first is going to be one way to test for water quality. The second will be a different way to test for water quality. Students are going to give you an idea about what those tests are in general. We're going to look at 3 of them, one of which we'll not necessarily do today. And the first of that is a test for visual ideas when we look at water quality. So Justin, come on over and join me. Justin here from McClure North High School, who's going to talk a little bit about visual tests and how you do a visual test to help determine water quality. What does that mean exactly, Justin?
A visual survey is a study of the surroundings of a creek. And a good creek has vegetation, so it stops the soil from going into the water.
So actually, as we actually look at some of the video that we're seeing right here now, the Little Creek area, which is you guys doing some other collecting on different days, and we look at the vegetation here, you want this kind of stuff around the shore's edge, you're saying. You want green stuff to be growing, right?
Yes.
And obviously the water quality is going to be affected by, like, if it's a rocky terrain or it's just a whole bunch of soil, because erosion is going to occur, and that would definitely affect the water quality that you're getting.
Yes.
So we're not, when you talk about a visual test, then we're not just looking at what the water looks like, you're looking at what the surroundings look like, which would affect the water.
Yes.
Very good. Thanks, Justin, very much. Look forward to connecting to you and talking on more information throughout the program. So that's one kind of test that you can do. And obviously, to some extent, you've had a chance to do that today already because you've seen a little video of the Little Creek nature area. You see that there is vegetation around it. It's not like a whole bunch of, soil is immediately being dumped into the stream or the creek. And that's a good thing. They have collected water from the Little Creek area, and today we're going to do the other 2 tests that we're able to do because they've collected that water. The first of those is what's called a test for macroinvertebrates. And to talk a little bit about that, Mark, come on over and let us meet you, also from McClure North, home of the stars, if I'm remembering correctly, right?
Yes, sir.
So what is a macroinvertebrate, and why do we care about them as we test for water quality?
A macroinvertebrate is basically just a small little organism. It doesn't have a backbone, and they're small enough to where we can see them without the use of a microscope.
And the kind of macroinvertebrates that live in the water help us see what kind of water we've got. Is that the way it works?
Yes, sir.
So then if it's water that we like, there are certain creatures we would want to see?
Yes.
And if it's water, and does the opposite work? Like if we see a bunch of a certain kind of creature, should we be thinking, oh, I don't want to drink from that stream?
Not necessarily. It's just different qualities.
Okay, very cool. You guys are going to have the chance to actually see some macroinvertebrates in just a bit when we do that test. Thanks very much, sir. And lastly in the program today, we're going to do chemical tests for water quality and talk a little bit about that. I'll invite Ash to join us as well so we can have some basic information set up for that. Ash, thanks for being here. So when we look at chemical tests, what do we mean?
Chemical testing is the last way we test for water quality. Chemical test is basically like using your chemicals. There are several tests in chemical testing. You could do phosphate test, nitrate test, dissolved oxygen in water test, pH levels, water temperature, and also turbidity.
Very good, and we're going to have a chance to look at all those things that Ash just talked about, nitrate, phosphate, turbidity, pH levels, as we do those tests later today. Thanks, sir. Looking forward to it. You've collected some samples like last night and this morning. Talk about how it would normally happen, what you did, and we'll get started.
All right, so typically our students, like you would see on the video, they've collected water, and we would do this at a spot at the creek. Typically we would do this at maybe 3 different locations along the creek to get a good idea about the water quality at the creek. And what we're going to do today is kind of give you a snapshot of one location at the creek, and we're also going to pull in our pond. We have a pond that the water does eventually run to the creek, but we want to check out the quality of water at the pond and the creek. And so the students will be looking for the macroinvertebrates like Mark had spoken about in the creek. There are certain macroinvertebrates that are helpful, that can live in very pristine waters, the non-polluted waters, and then there are some that can live in really polluted waters. And so what we're looking for is if we can see some of those organisms that live in the type of water that would be not so polluted waters, or is it maybe polluted? So we're going to kind of see what organisms that they find today.
And to our interactive student groups, we know that you received in advance some materials which gives you the same kind of materials that the students are going to work with here. If I walk over here to Mark and Ash's table, they've got the same kind of identification card that we sent all of you guys in advance, which they're going to be looking at themselves, as they try to figure out what kinds of creatures we actually have living in this water here. They're going to be recording that data onto sheets then, and what we're going to be able to do is compare pond water versus creek water. So as we begin to do that, we're going to be interested in your questions that you might have for Jamila and Perry about the conservation and water quality in general, and then what questions emerge for you guys as we see what's here. So guys, shall we start? I'll give that back to you, and I'll let you guys go for the gusto, and we'll see what pops into our Petri dishes and what ends up under the microscopes as we look for those items. Now, as the students begin to work here, Jamila, when you guys are looking at water quality from the Missouri Department of Conservation perspective, we'll move out here this way because I know Caitlin needs to work. Are there certain kinds of tests you do in separation yourself or in conjunction with Missouri Stream Team that are part of help you determine what is the quality of water and what kinds of things you need to do?
Yes, Stream Team is one of our citizen science organizations that assist us with collecting data throughout the state. So they're a volunteer group that will adopt a waterway, and they'll do water quality testing, macroinvertebrate sampling, litter pickup, and then they'll take their results and submit them to us, and it gives us a better track of what's going on in all of our waterways throughout Missouri.
And to the schools that are joining us interactively, it's through Missouri Stream Team and the Department of Conservation here that you receive these materials in advance, and we highly recommend that you go to their 2 websites to learn more because there's lots of great stuff out there for you to do. Thanks, Jamila. So students are beginning to find some stuff. I'm going to go over here to Mark and Ash, who are beginning to look at some things that they're going to pull into their Petri dish. Oh, and it looks like we've got a small little creature that's already begun to emerge, and Pete, if you can get us an overhead shot of that, that's excellent. Students, if you have your sheets in front of you to identify the object, you might want to be looking at that as you do. Mark, as we look at this little guy here, what kind of creature does it look like you think we're dealing with?
We are dealing with a crane fly larva.
And you know it's a crane fly larva because?
The obvious pricks at the end of its tail right here, and the darkness of its head. We can see it right here.
Oh, very good. Now, a crane fly larva, does he live in a certain, is he more likely to live in a certain level of water, quality of water level?
He prefers to live in only a type 1 water, which basically that is only a group 1 taxa.
So that's like really high quality water, or the best water one would potentially have of the 3 different levels?
That's right.
Okay, very cool. So that's probably a good sign then. Now this little guy is really little. Shall we take that Petri dish over to the microscope and let the folks see him up close? Yes, we should. Okay, we'll carefully walk over to the microscope, hopefully not dropping our little creepy crawly as we do so. So you guys are able to see this one a little bit more up close, and you're going to see he's very, very different. We'll put him underneath here, and as we begin to focus in and we switch to the camera, oh, it looks like we're in pretty good focus already. That you guys can see it. I'll try to sharpen it up. Ooh, too far. Tim goes too far. Try to sharpen it up a little bit. And this is obviously a much smaller guy that we've got going here. What do you think we've got here, Mark?
This is a scud.
A scud?
Yes.
And a scud is?
It's only a small little organism. It's just like a small invertebrate that we can just barely see, though.
And does the scud like to live in really good quality water too, or is he a little bit more tolerant?
He's just as tolerant as the worm.
Oh, okay, very good. Looking at these kind of examples, questions that have popped into your mind either about these creatures or other thoughts so far, go for it, Jamestown.
What's the most common type of macroorganism?
Is there a kind of common creature, Eric, a common macroinvertebrate that you are going to see that in this area of the world, so to speak, we might see more frequently than others?
At Little Creek anyway, in our creeks we find a lot of scuds. In terms of macroinvertebrates the kind that we're looking for, there's a lot of scuds that show up.
Okay, very good. Thanks, Jamestown. Let's go back to Arts Academy at Summit again. Arts Academy, a question from you.
What will happen if you drink the water with the organisms in it?
Oh, what happens if you drink the water with the organism in it? Well, Perry, I'll ask you to come forward a little bit because we can talk a little bit about water quality. And now, I don't think in this instance we're necessarily talking about chocolate-covered scuds in the same way you might have chocolate-covered grasshoppers. But, I mean, is there something to be concerned with? Just think about it in a general nature about going out and you're out hiking in the woods or whatever. Do you need to check for something before you decide, I'm just going to drink from the stream?
I just highly recommend not drinking directly from any stream. There's going to be a lot of microorganisms in there that are going to give your stomach a little bit of an issue that you probably want to avoid in most cases. As far as these macroinvertebrates, though, they're probably just going to give you a little bit of protein.
A little bit of protein and hopefully not too much heartburn along the way. Thank you, kind sir, and thanks for those questions. Caitlin, I see we've got some other good stuff popping out here. Oh, all right now. I see you've decided to bring us big sample for sure. And I'm going to lift him up a little bit and bring him out here. So I know I'm dripping some water. So Pete, our handheld camera person, is able to see him a little bit, and then we'll just dry the area up. And I'm going to go to Jamestown, Missouri. Jamestown, you may be able to identify this guy just from your own personal experiences. What do you think this creature is, Jamestown?
Crayfish.
It is indeed a crayfish, and he's having a good time swimming around the water there. Now, Caitlin, is this a rare find here at Little Creek? You see this a lot, and what kind of water quality does he like?
From the Group 2 taxa of water quality, which is an intermediate quality of water. Now, he is extremely large for what we would normally find. Normally find a lot of baby crayfish and a lot of medium size, but he's a very nice find.
He's a very nice find. I guess, you know, you could have a little crayfish later. We could do a little crayfish feed. And he's a very active little guy, too. He is ready to move around. We need to get you in more water. Wait a moment. Let's do a quick interview. Any thoughts about your first time on camera? Interestingly enough, he has nothing to say. So there's crayfish 1. And now you want to bring these 2 over where we can see them better a little bit under the microscope. And we're going to see a couple of different examples. And I'm going to go to Arts Academy at Summit so you guys can give a guess as to what you think this might be, and you may or may not know. So don't let it worry you if the guess isn't accurate, but let me move him around a little bit so you can see. There he is. Arts Academy at Summit, as you look at this guy, do you have any idea who you think this might be?
Dragonfly. Water spider. Water spider. Water dragonfly. Water spider.
Dragonfly, both of which I think are potentially good guesses, but maybe very different. Caitlin, what do we have here?
These are 3 different sizes of damselflies.
Damselflies, okay.
So they are, if I remember correctly, they're from Group 2 taxa as well. So intermediate water quality, and we find them pretty often, so it's a very good, interesting find.
Very good, and I know we've got some slides. You guys can now see a close-up picture of a damselfly, what they look like when they're not being looked at through a microscope. And obviously, as we look at it, he has a tendency to look a little bit like a dragonfly in some ways, but he's different. So the same kind of an intermediate level of water quality that's looking good for him here.
They do look very similar to the dragonfly nymphs, and they're both in the same family, so that would be why they look like each other.
Okay, very cool. Thanks very much for that postulation, Arts Academy. And now we're going to move over here to Justin and see what interesting, different little creepy crawly creatures Justin has found. And let's start with this Petri dish right here at the beginning. And again, we'll let the students just look at them a little bit, and we'll bring it over to the microscope, and then we're going to bring another little guy with us as well. So Justin, I'll let you slide in front of me there and put that under. And this may or may not be a creature that Jamestown you're going to recognize, but we'll switch and bring this one up for you. Whoops. Bring him down because he wants to move around a lot. I'm going the wrong, whoops, wrong direction. Bring him into focus. That's about as good as we can get. Jamestown, I'm actually seeing a couple of different creatures in here, so you might choose to guess either one of them right there. But Jamestown, what hypothesis do you have? What do you think we might be looking at here?
Soapbug.
Soapbug.
Oh, okay. And Justin, what do we have here?
We have a snail.
We have a snail, and that's the little guy, obviously, right there.
And a dragonfly nymph.
And that is a dragonfly nymph. And so talk to the students a little bit, nymph in terms of like, you know, how creatures develop. A nymph is like going to become a full-fledged dragonfly eventually?
Yes.
And in terms of quality of water, are they pretty tolerant as well? Or
They're pretty tolerant.
So they're like a level 2 also?
Yes.
So we've got some good quality, water quality tolerance there. And then we'll switch these guys out and we'll go to our personal friend here so we can hopefully see him both from above and below. So Pete, if you can move and want to get him from a side shot and that works for you, that's absolutely great too. But we'll bring this one in, and Arts Academy at Summit, I'm going to have to shift him around a little bit because he wants to move a lot. Let me go there. Whoops, keep him moving. There he is. Arts Academy at Summit, what does this creature look like to you as we begin to look at him? That's what I'm talking about, yes, with 100% accuracy. And Arts Academy at Summit, this tadpole eventually is going to become a what? Now we're talking good. Now we're talking good time stuff. Oh, Arts Academy, do you think a tadpole would like really good quality water? It doesn't matter, maybe intermediate quality water, or he could live in even bad water. What do you think? What kind of water do you think a tadpole would prefer? Yeah, I hear all sorts of different possibilities there. Thanks for muting again. Justin, what can you tell us about this? What kind of water quality will a tadpole survive in?
It really doesn't matter.
He likes just almost anything, right?
Yes.
So, and this would be the right time of year to always be seeing tadpoles, I'm assuming, right?
Yes.
Very good. So the tadpole, once again, has shifted a little bit, but we'll move him there so you guys can see him a little bit better. He just wants to continually slide around and swim for us. But there he is, and there he goes. There's part of him right there. Happy little oh, look at him flitting around. Happy little tadpole, soon to become a frog. Let's go to Jamestown. Do you guys have any questions you want to ask? And then I'll come to Arts Academy in just a sec. Jamestown, go for it.
What's the least common macrotype?
There's several. The mayflies we don't see very often. The water penny I haven't seen at all. The stoneflies we saw once or twice last year. So.
Okay, good question. Let's go to Arts Academy at Summit. Another question from you?
All of the organisms in the water.
Talk a little bit about the organisms you get, the sample size you're working with, that kind of thing.
We do take a limited sample size, but all the organisms we're looking at are aquatic, so they do live in the water. Some of them, like the dragonfly, the damselfly, those are nymphs, so those are young of the adult dragonfly. So they will eventually grow into something that lives outside of the water. Some of them will remain in the water their whole life. The scuds, the crayfish, some of the others the snails, they'll be aquatic their whole life.
And the students are going to begin to record their data. We're going to look at their sheets of information in a bit, but Perry, I'll invite you to come over for a couple of questions as the students record the data. Now, as an urban forester, you're obviously not looking at aquatic life, really, are you at all? I mean, you're mostly just looking at trees, but can this kind of like, seeing the kind of aquatic life that's in an area, does it cause you to think about what the tree health might be?
Absolutely. What happens in the stream will tell you exactly what's going on up on the ground around it.
Okay, so like, to talk in terms of like some examples of that, like if I've got really poor quality water, then I'm assuming vegetation's going to change. Will I necessarily have less vegetation, or will it just be a different type?
It could be less vegetation, it could be a monoculture of vegetation, it could just be no vegetation, like in the case of an urbanization where we've cleared everything and built over the entire ground and just have maybe one or two street trees here or there, something like that. You're going to have a vast change in water quality and the creatures you're going to see down in the water.
Oh, very cool. Let's go to a couple more questions as students are going to begin to show us their results. Jamestown, Missouri, go for it. What's the question you want to ask?
If you drink creek water that these organisms are found in, can it be fatal?
Anything that we have to worry about in terms of bad illness, fatality, or?
In the organisms that we're finding?
Right.
The organisms that we're finding, like Perry said, probably just give you a little bit of protein, but there would be other organisms in the water that could be harmful.
Okay.
Give you a little indigestion.
Yes, and that's not necessarily a good thing. I want to come over here to Ash and to Mark, because I know you guys are in the process of identifying. Oh, and look, I assume, Ash, that we've got a second little crayfish happily joining us?
Yes.
Very nice. Got a nice little crayfish joining us happily here.
That's the big one,
That's
and we got a small one.
Oh, you've got a little baby crayfish as well.
Yeah.
I don't know. Is baby crayfish the right term? Okay, very good. Not a crayfishette or a crayfishlet. A baby crayfish. Very good. As you guys look at the crayfish here, I also noticed that you've got drawings that you've put here. Ash, talk to the students a little bit about recording data and why this is so important.
We need data to identify which taxa they are in. If it's group 1 taxa, which means it's an excellent water quality. Group 2, it's a fair quality. And group 3, which is, not so good.
Not so good.
Not so good.
Arts Academy at Summit, another question from you.
What do the vertebrates eat?
What do these kind of creatures eat? So these macroinvertebrates are eating what kind of stuff, Eric?
It depends. Some will just eat the microorganisms around them. There might some that will eat some of the other smaller macroinvertebrates. So it depends on what it is, but so they can eat each other, or they might eat some of the algae and things like that's around in the creek too.
Oh, very good. And we've had some email questions that come in, so let me go to the trusted little iPad here and see what we've got. Thank you, Shawnee, for sending us some email questions. So, like, is there a general kind of sense, like per scoop they ask, how many invertebrates are you likely to get per scoop?
That's a great question, and that just varies. You might be lucky and you can pick up 3 or 4 in one scoop, or you might get nothing. It just kind of depends on where you're at in the creek.
And you've obviously been doing this for a period of time, and this is an interesting email question about recording data from year to year. Have you noticed anything over time yourself about the change in the water quality here or anything?
Definitely. The few years ago, we were not getting many macroinvertebrates. The macroinvertebrates that we did get were not quite as good as the ones that we're getting now, and they have definitely improved over the last few years. There's been a lot of work done at the creek, and Perry has been an integral part of that, working on our watershed and making many improvements here. So we have seen an improvement in terms of the macroinvertebrates that we have.
Very good. I want you guys to have a chance now to hear from the students and see what they think might be the nature of the quality that we're looking at. Because Caitlin, I see you have been obviously recording all sorts of data here that we'll see, and I'll turn it the right direction so the students will be able to read it. So talk a little bit about what you found, because it looks like most of them seem to fit into the second category.
I ended up finding a rifle beetle, which is the tiny little swimmer that's running around in here, and then I found 6 whole scuds, so very excited.
It's kind of like fair to midland water quality is what we've got here. Very good. And that guy is indeed, that little beetle is happily roaming around. And Mark and Ash, did you find similar? Lots of 2s, lots of 1s? What have you guys noticed so far?
We found a lot of
What's good? More 1s?
Yeah.
Okay. And so these are both examples from the creek water. We're finding lots of 1s and lots of 2s in the creek water. And Justin, I know you are dealing specifically with the pond water. Anything different, or are you finding lots of 1s and 2s? Looks like you got tons of 2s.
Yeah, I got tons of 2s.
So he's got tons of 2s. So that's pretty, you would expect, I'm assuming, you would want to find some degree of consistency between the 2 sources.
Absolutely, especially since it's all part of the same watershed, so you would expect it to be pretty similar, but yeah, if there was something different between the pond and the creek, you'd know there's something going on between those 2 sources, but yeah, you would expect it to be very similar.
Very good. We're going to begin now to move to our second lab activity, which is going to talk about testing for water quality, those chemical tests we talked about. So I'm going to let the students here switch out a little bit, put those little macroinvertebrates back into those nice little plastic containers so they can switch out and begin to think about testing for water quality through the chemical stuff. I want to go to each of our school groups to see if you have a question right now, though, while they do that. Another question from Jamestown, go for it.
How big is a water coon larva?
When we think about a size for that, Eric, a water...
Pretty small, maybe the tip of your finger size, pinky size.
Okay.
It's pretty small.
Very cool. And another question from Arts Academy, go for it.
Polluted water affect the organisms that live in it?
Does polluted water affect the organisms that live in it? Come on out and join us, come into the light. I would assume the level of pollution would affect, because obviously certain creatures wouldn't like to live in certain places.
Exactly, and that's exactly what the students are looking at on that sheet. If there are certain species that do really well when the water is really clean and they're very sensitive to pollution. There are some that are more tolerant to pollution, so it does change the type of species that you'll find in the water.
And talking about pollution, pollution is also going to show up in the kind of tests that we're going to do now when we look at the chemical testing for water quality. Jamila, thanks very much. You may remember from the description that Ash gave at the top of the program about testing for water quality, the chemical test. We're going to look at a number of different factors. We're going to look at phosphate, we're going to look at nitrates, we're going to look at dissolved oxygen, we're going to look at pH levels, and we're also going to look at turbidity. We're going to start by looking at what is called dissolved oxygen, and I'm going to return to Caitlin so we can talk a little bit about dissolved oxygen. And Caitlin, what is dissolved oxygen? Why do we care if dissolved oxygen is in our water?
Dissolved oxygen are just oxygen molecules that have been incorporated into water as like a byproduct of photosynthesis and aquatic plants and turbulence in the water. And bottom line, all animals need oxygen to breathe. It's very important. You can't have it without it.
But you can't have too much dissolved oxygen in the water, I'm assuming.
You can have too much, but usually you want a really high number.
Okay, so now what are you going to do the test?
The test is very simple, very easy. All we do is we take some of the creek water that we've already collected and put the water in the test tube. We're going to use 2 tablets.
Conveniently located inside our plastic baggie.
Mm-hmm. And then for 4 minutes, I'm going to invert the tube back and forth to dissolve the tablets. And then after 5 minutes, we'll wait and the color will change and it'll show us, based on this chart over here, what our levels of dissolved oxygen are and what that means for our creek.
And let's pull that out so the students have a chance to see it now so we're aware of what's going to happen. This is the dissolved oxygen. You'll see a color chart here. And we also have a slide image that we can bring up as well. But ideally speaking, we're looking for something that's lighter color, not darker color, right?
You want a darker color for dissolved oxygen. It is more in the water, so there's more.
Oh, you want to go dark. Very nice. That's a good thing to remember because it's a little bit different for some of the other things we're going to look at. That's great. So in this instance, we're going to want a pretty nice pink to emerge.
Yes.
So remember that, folks. We're going to be looking for a pretty nice pink to emerge when we come back to this. But that's going to take a while, so I'm going to let Caitlin finish that process because we're going to go to Ash and talk a little bit about pH next because this test is going to take a few minutes to do as well. So Ash, what is pH first and foremost and why do we care?
pH is actually the hydrogen ions in water. So if it's, it has a scale from 1 to 14. 7 is the neutral, which is our drinking water, which is good for us. And anything above 7 is acidic, and anything below 7 is basic.
So you guys are going to collect a sample of water similar to what Caitlin just did, and the students are seeing now up on the screen just saw the different color choices. And ideally speaking, you guys are looking for something in the green range, if I remember right.
Yep. We're looking something between 7 and 8.
Okay, we're looking for something between 7 and 8 in that green range. Go ahead, Ash, and go through the process. And you're going to drop in a couple of tubes or a couple of little pills yourself, or just one?
No, not for me, but for this one, we're going to drop only one.
Okay.
And we fill this with 10 ml.
So you've got 10 milliliters of water that are going in there.
Yes.
And one tablet's going to go in there. And then how long does this test take before we can find out exactly what's happening?
This might take 3 to 4 minutes.
Okay. So we'll let you do that. Take 3 to 4 minutes there. We've also got the dissolved oxygen test working, and we know you guys are probably thinking of questions you want to begin to ask. Before we come to you for questions on these tests, we also want to go back out to Brianna and Evan, who are joining us from the Little Creek area down there actually at the creek stream, because they're going to talk about the turbidity test and what it does. So Brianna, come on in.
Hi everyone. Evan and I are here to test the turbidity of water here at the creek.
Yeah, hi, I'm Evan from McClure High School. We're just going to take a sample of the water in the creek real quick in this little bucket. Alright, then we'll take our little note card and we will see how dark the black spots are in here. They look to be pretty dark. They aren't quite 100%, you know, they aren't at 0 JTU. I'd say that they're at about maybe about 15 to 20 JTU. So I'll write that down right here. And JTU pretty much the turbidity lets us know how contaminated and how much sediment is at the bottom and that's in the creek. Because sediment, if there's too much sediment, it'll get in the fish's gills and lungs, and, well, they'll pass. So, that's turbidity right there.
Well, thank you, Evan.
Thank you.
Now let's go back to Tim.
Thanks very much, Brianna and Evan. That's absolutely great. We're glad to see that turbidity example that you've got there. And Eric, let's do a couple of clarification things based on what Evan and Brianna just talked about. He mentioned something called JTUs. And what are JTUs?
The Jackson Turbidity Unit.
Sounds impressive. And I care about that because?
Well, we want to make sure if the turbidity is really high, then there's a lot of sediment, soil in the creek water. And that's not good because these macroinvertebrates, fish, they have gills, and that sediment can get in the gills and can suffocate them. So we want that number to be low.
Very good. And I just heard word that we got a tweet from someone concerning this turbidity information. So that tweet information could be repeated in my ear. I'd like to bring that up because I think it's a question that we'd like to ask here. So oh, that's great. Kevin Hampton from McClure North. Thanks very much for that information. He just had a tweet from someone who works in an environmental testing lab talking about the fact that this kind of equipment and this kind of test that they do on a regular basis as well. So that's very cool. That's absolutely great to know. So, Caitlin, should I come to you yet, or we still got some time?
We still have some time for this one, but we can do the nitrate test if you want.
Let's go. Let's do a nitrate test then. So remember, dissolved oxygen is still sitting here patiently waiting. But what about nitrates?
So nitrates are just as important as dissolved oxygen because they're needed for all organisms to build proteins. And earlier you said that we wanted a lower number. That's the one we want the lower number for in the nitrates.
So we definitely, on the nitrate level, we want it to be something in like the 5 parts per million. We don't want something that's going to give us like a Pepto-Bismol color.
Definitely.
Okay, so the process for you is going to be the same?
It's going to be the same. I'm only going to use 1 tablet. I'm going to fill this up to 5 millimeters and oopsie.
Oh, what's a little bit of water spill?
It stayed in. And 1 tablet.
And you have to shake for a bit, and how long does this one take for us to figure out?
This one takes about 5 minutes, and then we'll start to see our nice pink color, and then we can decide how much nitrates we have in our water.
Well, we'll come back to you in a bit for nitrate and dissolved oxygen. Don't forget we have to return to the gentlemen, Ash and Mark, to talk about pH levels. But let's go over to Justin now before we go to your questions, because you're going to be testing for phosphates, right?
Right.
And so, Justin, talk a little bit about phosphates. What difference do they make, and why do we care about them?
Phosphates occurs naturally in rivers and streams. They help plant life grow, but too much phosphates can lead to overgrowth of algae, which depletes resources like dissolved oxygen and water.
So obviously we want less phosphate, not too much phosphate.
Yeah, less.
And in this instance, we're going to get something that's going to be blue. As we look up on the slide, we can see it right there. So we're going to get a different color of blue. And so go ahead and go for it, Justin. And this test takes a few minutes to figure out too, am I right?
Yes.
So we'll dump, and you're going for the same amount of water, and you're going to put 1 tablet in, or a couple?
1 tablet.
1 tablet. And we're going to end up with something that's going to be some shade of blue in a little bit. We'll find out what that is. Students, you probably have questions about some of these items we're talking about: nitrates, phosphates, turbidity, pH levels, dissolved oxygen, etc. Let's see what questions you've got, and don't forget you can email us your questions to live@hectv.org. I'll go over and check those right now. Jamestown, Missouri, a question from you.
How do you determine the quality of the water when you have different results from different groups?
Oh, that's a really cool question. Jamila, you want to talk a little bit about that? If you start getting different results from different water samples, how do you determine quality? How much of a sample size do you really need to feel you're getting a pretty accurate reading?
Well, like with any science experience, you can't just take 1 sample. You have to have multiple samples in order for your results to be accurate. So in here, they just have 2 samples from the creek and 1 from the pond. So we would definitely have to go to different areas and do multiple samples to see if we're coming up with the same results.
Very good. Thanks, Jamestown, for that question. Arts Academy at Summit, a question from you.
What's in the tablets that make it change colors?
Oh, very cool question. And I'm seeing all sorts of people go, I'm not sure I know the answer to that question. Caitlin's saying, don't come over and talk to me, Tim. Eric, Jamila, Perry, anything at all? Do you know what's causing the reaction? What's in the tablets?
No, I'm not sure.
Magic. This is one of those fabulous moments when we say, look up that information and let us know, because research would be really cool. I think that's an absolutely great question, because obviously something's going in there to cause the reaction. That's a great question. Great question, Arts Academy, but we don't have the answer for you right now. If you find it out during the program, feel free to send it our way. We've got to take a few more minutes here before we get test results. I can see something starting to happen with the pH level, and it looks like something's starting to happen with dissolved oxygen. But before we get there, let's go back to Jamestown. Another question from you.
What's the best type of water quality you've gotten?
Oh, obviously, anything, Eric, in terms of the best kind of water quality that you've had here?
It's another good question. We, at Little Creek, we tend to get pretty good results. Our dissolved oxygen is usually pretty good. Whenever we've done the test, the phosphates and nitrates have been pretty low. So we get pretty good results. We never are pristine, excellent, or anything like that, but they're pretty good. They're pretty good.
Now, Perry, these same kind of tests are being done in like drinking water systems more frequently. Like if I'm like the City of St. Louis water system, or Jamestown, Missouri, and obviously Canton, Ohio, they all have water systems. Are they doing tests for these same kinds of things?
Yeah, they're probably not doing macroinvertebrate tests, but they're doing the same chemical tests, probably, and a lot more extensive, a lot more exact. These are kind of broad tests that we do here. And yeah, they're going to do those continuously, so they know how to treat the water and how good the water's coming out after they treat it. But again, these tests aren't quite that thorough, but one of the ways that they are thorough is that when you combine the macroinvertebrate tests with these chemical tests, that's kind of, we were talking about just having one sample, but we're actually testing that sample in 2 different ways, so it's a way to corroborate those results. Like if one says pristine and one says really bad, you obviously have done something wrong.
Right, something has to be tested again.
Exactly.
That's good information. Arts Academy at Summit, another question from you.
Does natural disaster debris falling in ponds absorb any natural chemicals?
Excellent question about natural disasters, the effect of chemicals from a natural disaster because certain minerals might be in the soil, that kind of thing. Erosion, Eric?
You would definitely see an effect after a natural disaster. You're going to have more erosion because there's going to be a lot more debris and things like that. And certainly, depending on what's around, you could have other kind of chemicals, fertilizer and things like that could come off more quickly. So it would definitely affect the results of the quality of the water.
Well, and you mentioned fertilizer, and obviously we're looking at phosphates, we're looking at nitrates, and they exist in fertilizer. If I'm going to use it on my lawn, I'm going to use it on my farm or whatever. So some sort of natural disaster which might cause a lot of soil shift, and all of a sudden an increase in fertilizer runoff comes from farms could affect you guys downstream.
Exactly.
Let's see what our results are. Caitlin, do you think we're ready to look at some dissolved oxygen possibilities? All right, so we'll bring up the slide as well that shows dissolved oxygen, and I'll hold it here in my hand too. And we obviously have something that's pink in color, and as you look at it, what does your trained eye tell me, Caitlin?
It's a little bit difficult to see from right here, but it's in between the 4 parts per million and 8 parts per million. So about 6 parts per million. It's been sitting in the classroom for about the hour, so a little bit of the oxygen is out. But we end up having about, at 20-degree water, we have about 66% parts dissolved oxygen.
Very good. So we've got that's a good thing, right?
It is.
We want more dissolved oxygen. So that's a good thing. So as we begin to look at these results, we're also going to compare these results from the creek to the pond, so we get a chance of seeing exactly what the water quality is here. Let's go to the wonderful world of pH testing, and I'll hold it and just hold it for us in front, like onto the side there, so we can see it as compare. What do you think we've got here, Ash?
I think we got something between 7 and 8.
And that's a good thing, right?
Yeah, 7 is neutral, which is like the fresh water, and 7 and 8 is for like a pond. So
because we don't want to become too acidic.
Yeah, we don't want to be
acidic makes really poor water quality in terms of like people's health.
Yeah, right? The animals would be dying if they're in. Yeah.
And that would make for a sad show, and we don't want a sad show today, so that's a good thing. Thanks very much. And are you guys looking at pH? You're also recording data for very good, and I see we've got lots of good information that you're getting there. Let's go, Justin. Do we have a phosphate result yet, or do we still need to take some time? Oh, we do. All right, again, hold it right there next to the white so they can see the comparison. Now, ideally speaking, Justin, we're looking for something that's a light blue, correct?
Correct.
And in this instance, there's hardly any blue tone or tint to it at all, it looks like to me.
Just a slight.
Just a very slight one. So we're dealing with very small parts per million, easily 1 or less, it appears.
Yes.
Parts per million in this particular sample. And I'm assuming that's a good thing.
Yes.
Okay, very cool. So there you get some phosphate results that they're going to look at. And I'll head back over here to Caitlin, because don't forget, she wasn't just Miss Dissolved Oxygen, she was also Miss Nitrate. And Caitlin, when we look at nitrates here, again, we're going pink, but lighter is better, right?
Lighter is much better, and as you can see, there's barely any color to it whatsoever. So we have a very good test result here. Very low, less than 5 parts per million, and very good sample.
Thanks very much, Caitlin. I'll let you record data. Let's go back to our student groups to see what additional questions they have, and I'll check email questions too. Jamestown, Missouri, come right on in. What's the next question that you have?
What can we do to improve turbidity?
That's an excellent question, and all of you could probably deal with that a little bit, but I'm assuming one thing you definitely want to do is make sure that there's not very much erosion around the areas. Would that be an accurate statement?
Yes, you definitely want to plant trees, plant plants around your waterway, because those roots actually hold the bank together and stabilize that soil, so you won't get a lot of runoff into your sediment.
So less runoff, the better.
Yeah.
And so from an urban forestry perspective, that's something you're looking for all the time.
Well, heck yeah.
Okay. Now talk a little bit about how the urban environment affects, water quality, because you get so much runoff, you're not necessarily, you've got all that asphalt pavement and it's just going straight over and that kind of thing.
When we have asphalt, concrete, any of those impervious surfaces, water hits those things and takes anything that's on top of that, it's going to wash off in the creek, and that's going to change water chemistry. It's going to change temperature quite a bit, actually, because those surfaces heat up and that water heats up when it hits. That's going to affect the water as well. The other thing that it does, especially when we get into the sediment issue, is it's really not eroding the concrete and asphalt so much, but all that extra volume of water and all that extra energy that water has, because there's nothing slowing the water down anymore. Once it hits the creek, it really starts eroding the creek itself, the banks and the bed, and that increases a lot of sediment, a lot of the turbidity there. And one of the things we've done here is to try to stabilize those situations so we get a lot less sediment in the creek, and I think that's one of the reasons why our water quality is going up here.
And Perry mentioned temperature, Eric, and temperature is one of the things that you guys look at here as you look at your results, right? When you talk about you want dissolved oxygen, the temperature of the water matters as you begin to look at those charts, right?
Right. If the temperature is a little bit high, sometimes that can make a difference too. And if the creek or the pond were to heat up a little bit, there's going to be more growth, and that sometimes that growth can take away the oxygen. So that the cooler the temperature, the better.
Okay, very good. Arts Academy at Summit, another question from you. Come right on in.
Do chemicals change colors?
What you'll notice with the dissolved oxygen, they had to sit the dissolved oxygen for another 5 minutes after it had been mixed for 5 minutes, so it could slowly get to the color that it needs to be. And then after it sits another 10, 20 minutes, that color slowly fades. So these chemicals can change color with time, so you need to get it just the right time.
Look at the results from the pond and the creek and see how you would summarize the results. Do you think this looks like excellent quality water, good quality water, or heaven forbid I should ever want to put my toe in that quality water, as you look at these kinds of results? So as we move over here to where Pete is, you guys are going to see, we'll just hold that for a minute and just look at what they're telling you in terms of location of the creek, dissolved oxygen, and then please note they've got measurement, what they're looking at. They're looking at the result, the level of the dissolved oxygen or the level of phosphates, and then they're trying to determine its significance. Is that a good thing, a bad thing, an excellent thing, or whatever? And as you guys look at the adjectives that they use to describe the significance, if you had to take all of these results and put one word on it, Jamestown, would you say all these results add up to good, very good, excellent, bad? What would be a word you would toss out, Jamestown?
I think it's fantastic.
Good.
Fantastic and very good, excellent. I hear that from you guys. Arts Academy at Summit, would you agree? How would you describe these results that you just saw? And may I say, I'm very impressed, Arts Academy at Summit, of your ability to hold that note for as long as you did, as you told me good. Nice breath control as well as information. Eric, would you agree with what the students from Jamestown and Arts Academy at Summit are saying, that we're looking at pretty darn good water quality
Yeah,
here?
it's good water quality. Kind of follows along with what we saw with our macroinvertebrates.
And is that generally speaking what you have seen over time in this location?
It has. These results are very similar to what we've been able to get year after year.
Now, just about a year ago at this time, this area of St. Louis County actually experienced a pretty large tornado system that went through.
That's right.
If I remember correctly, it was Good Friday of last year. And did you guys notice, as a result of wind damage, of trees going down, did you see any change here, even though obviously you weren't right where the tornado was located? Did you guys see anything happen in terms of erosion and stream quality as a result of that event?
We did, at the creek especially, because there was a lot of rain at that time and there was a lot of wind and disturbances. We did check out the creek right away. We did not do the tests, but we did notice there was a lot more sediment and erosion that did occur at the creek. Now, with some of the improvements we've made, I don't think it was as bad as what it could have been, but we did notice it.
Eric, as you put everything into context from today, and you were going to end this class normally after your students had done a lab, what kinds of things would you like the students and the rest of the world out there to think about as we look at the data that we developed and just the testing process?
Well, first, one of the things Caitlin spoke about was the watershed. And what is your watershed? We all live in a watershed. What can we do to help improve that watershed? We have some results here. Good. How can we make those results even better? How can we maybe get the mayflies in there, which are really found in pristine water? So what are some things that we can do to better our watershed, especially as we think about Earth Day and coming up and doing what we can for our environment?
And speaking about doing what we can for our environment, Jamila, anything you'd like to add in terms of like how individuals could make a difference in terms of really thinking about how their actions impact environmental aspects like water quality?
Well, definitely. They can look more into Stream Team and see how they can become and want to start their own Stream Team in a volunteer organization where they adopt a waterway, do trash pickups, and start doing this water quality testing themselves.
And don't forget that most Stream Team's a great organization. They provide us with resources for this program, and you can see more about them at their website, moststream.org. And Perry, any last words you'd like to offer folks in terms of like from the urban forestry perspective? What should I be watching for if I'm sitting in it, about my tree dying or healthy or whatever? Are there certain things I should do in an urban environment different? I mean, Jamestown's a rural environment, but here in Canton, very urban. Should I be looking at something specifically?
It applies whether you're urban or in rural. The more trees or natural vegetation that you have around, again, the natural, the stuff that belongs there, that grew up there, the better off that stream's going to be. That's what the stream grew up with, evolved with. That's what it still needs.
Very good. Perry, thanks so much for joining us. Jamila, thanks so much for being here. Eric, thanks so much for being here. Mark, Ash, Justin, Caitlin, Brianna, and Evan down there, thank you guys very much. It was absolutely excellent to be partner with you guys. To everybody in the Ferguson-Florissant School District, to McClure North and McClure High School who partnered with us on this project, Missouri Stream Team, Department of Conservation, we couldn't have done it without you. We're really glad we were able to bring you here so you can see what outdoor education is like at this really unique place in the country. Bye, everybody. Look forward to another year of HECTV Live next September.